So we've got a scenario here where a car is towing a trailer and the car and trailer are going along at 12 meters per second. Now, given the weight of the car and the trailer as 1400 and 700 respectively, and there's restrictive forces on the car and the trailer of 630 and 280 newtons respectively, but the engine is pulling the car along at 2380 newtons of force. Now, what we want to do is we want to try and calculate, first of all, the acceleration of the car and the displacement of the car after 2, 4 and 6 seconds. Now, when we've done that, what happens is the tow rope now brakes. And what we want to do, we want to find out how long it takes for the trailer to stop and how far will it travel until it stops. So it's going along, we calculate these two, the tow rope snaps, and then what happens to the trailer. That's what we're kind of looking for. So first of all, let's have a look at the acceleration of the car. So we're just interested in what's going on here. We've got tension in here, but as we're given the forces all together, the tension is not actually required in this question. So we're going to use Newton's law of motion. Force equals mass times acceleration. So what we need to do is work out all the resolved forces and set it equal to mass times acceleration at the car. So at the car. So what we've got is 630 going the opposite direction of the car. So we've got minus 630. And we've got acting on the car, driving it, you've got 2380. So that's plus 2380. And that equals mass times acceleration. So that will equal 1400 times A. So that's the forces and then mass times acceleration. So it equals 1400 A. So let's put the 1400 A this way round. So we got, in this case, we've got MA here and we've got force here. So now let's work out what this is. So that's 1750. So 1400 A equals plus 1750. Then divide both sides by 1400. So A equals 1750 divided by 1400. So that will come to 1.25. So it's 1.25 and it's meters per second squared. So that's our first result taken care of. So that's our first one there. Now what we need to work out is displacement of the car after 2, 4 and 6 seconds. So this is the point where we need our Suvat equations. So let's write down here what we know and what we need to know. So displacement, that's what we need to find. So what we want to know is what's happening after 2, 4 and 6 seconds. So 2, 4 and 6, that's the time. S is what we need. Now U is the initial velocity. Well, initial velocity is going to be 12 meters per second because that's what the thing is traveling at. V, we're not actually sure what that is in terms of this part of the question, but we know what acceleration is, that's 1.25. So we've got S, U, A and T. So the Suvat equation we want for that is going to be S equals U T plus 1/2 A T squared, and solve for S with the 3 different values of T. So what we want, if we just put those in 3 equations with 2, 4 and 6, and we work out our answer. So S equals 12 times T. So let's work out for 2. So we call that S2. So 12 times 2 plus 1/2 times the acceleration, 1.25. So 1.25 and then T squared, as we're looking at 2 times T2 squared. And then I'll do the same, write these out for 4 and 6. So S4 equals 12 times 4 plus 1/2, 1.25, so that's going to stay. And this time I'm going to put 4 squared. And similar for 6. So I've got 12 times 6 plus 1/2, 1.25. That's my acceleration, stays constant, and then times 6 squared. Okay, so now plug all those into my calculator, and the first one we should get 26.5 meters. Second one we should get 58. And the last one we should get 94.5 meters. So I'm going to leave those for you guys to check the calculations, but that seems pretty reasonable here. As that's 24, that's going to be just over a half times 4. So all these numbers look reasonable to me. But leave the comments in below if you think any of these are incorrect. Okay, so that's that part of the system taken care of. But now the tow rope brakes. So now we need to work out something different. We need to find out what's now happening after the tow rope brakes. So this acceleration now will not be acting on the trailer. So we need to find out a new system of acceleration. So again, we're back to force equals mass times acceleration. Now what's going on at the trailer? Now there's no driving force, but there's a resistance force and the mass. So all we've got here now is a minus 280. So that's minus 280 equals mass times acceleration. So that's mass is 700 and the new acceleration is what we need to find. So now if I divide both sides by 700, so A equals minus 280 over 700. So that should give me minus 0.4. Minus 0.4 meters per second squared. So that's what I'm going to need to use in my new set of SUVAT equations. So for 3 and 4. So let's have a look at what we've got. So let's go for our values of SUVAT. So how long does it take for the trailer to stop? So T is something we need to find. How far will it travel in this time? Well, S is also going to be something we need to find. So there's 2 variables. Now we need to find U, V and A. Well, A we've got, that's minus 0.4. And U and V. So what is our U and a V? So U is going to be 12 because that's what happens at the start of the string breaking. And V is going to be 0 because it's going to come to a stop. So that's what we've got. Okay. So now we need to find our S and our V. Well, we've got S, we've got a U, a V and an A. So we're going to need V squared equals U squared plus 2AS. So let's put that in here. V squared equals U squared plus 2AS. So V squared is 0. U squared is 12 squared, so that's 144. I'll just write it in as that. And then 2 times acceleration times S. Now acceleration is a negative, so I'm going to change this sign to a negative. 2 times 0.4 and times S. So then let's bring this 144 over here. So minus 144 equals 2 times 0.4, so that's minus 0.8 S. So then divide both sides by 0.8. So S equals minus 144 over minus 0.8, which will come to 180, and it's in meters. So 180 meters. So how far will it travel in this time? It's going to be 180 meters. So I can put that there. That's the answer there. And then the last bit is we need how long does it take for the trailer to stop. So for that, we've got almost all of our things here. We just need to find T. So perhaps we could use V equals U plus AT. Okay. V, that's going to be our 0. U is going to be 12. A is minus 0.4, so I'm going to use minus 0.4 T. And can we get a T out of that? That's not going to be a problem. Bring the 12 over to the side. So I've got minus 12 equals minus 0.4 T. So in which case t equals minus 12 over minus 0.4. So t, plug that in there, you get t equals 30. So it's going to take 30 seconds for the trailer to stop. Okay, and that completes all of our calculations. Okay.